And I'm Quentin.
Yeah, and we're just going to go through a little bit about Rover today. But first of all, we just want to tell you thank you so much. The response has been overwhelming. And as of right now, I'm going to check it out. We have 1,081 backers, and that is...
Wow. Amazing, guys.
Yeah.
Thanks a lot.
Yeah, the vibe in the office is very high, and we're very, very stoked. So thank you guys so much. So a couple things. All of our early levels are selling out quickly. And so I just want to urge you, we have, let me look here. We've got 4,000 Kickstarter specials left for the Kickstarter special pricing for RVR. So get in there quick. And then we also have a few left on the Rover plus Bolt. And we're going to talk a little bit about that a little bit later and why that's cool. So you're going to want to check that out. But for now, we're going to jump right into Rover. And so we're going to talk a little bit about, this is a prototype, and I'll kind of walk you through a few of the features that come right out of the box. So here is our prototype, and when it comes, it's going to ship with a cover plate, which is actually removable when you press this button. When you remove it, there will be a cover on the chassis here, but you'll be able to look inside, see the motor, see the encoder, see the battery. You'll see the PCB layout and all that stuff.
And that's basically where all the sensors are on that PCB, which is very interesting to talk about maybe just in a little bit.
Yeah, and so if you look at the bottom here, this is where we have the color sensor, which is going to read RGB values. You can write programming based on what color it's recognizing. And then we've got IR sensors all around it. So IR here in the front, on the sides, on the back. And that is a really cool feature that lets you interact with other robots. So you can do swarm programming, you can do bot-to-bot communication, you can do following and evading. There's all sorts of cool stuff you can do with that. And then if you look down from the top, we have a ambient light sensor here where there's a cover plate. There's a hole here to let the light through. Oh, okay. We're having some technical difficulties. Are we good? Can you guys hear us? Comment if you can hear us.
Sounds great. Yeah, leave us a message. We'll be happy to walk through as many messages as we can, as we're so excited to have you guys here.
Yeah. What's that? No sound. Okay, cool. Give us a sec. We'll try to figure it out. Some people have sound.
Some people have sound. Okay, cool. Well, we're going to keep talking about the features and maybe go through some of them more in depth as we have technical issues. So maybe you can walk through maybe the infrared, and we can have a little demo and show them how it works. So Rover is compatible with the infrared with the current Bolt. So for those of you who are familiar with the features, Bolt here has like 4 infrared sensors. It has the infrared emitters as well, and Bolt is able to do some bot-to-bot swarming, and Rover will have the same capabilities. So I'm going to set up the demo. We're going to reset everything.
Yeah, so if you look down on our main Kickstarter page, there's a GIF, and it's also in the video, of Rover driving through some bolts, and all the bolts follow. That's a good demo, kind of like a beginner of what a beginning demo of what you can do with the Swarm robotics.
So I'm gonna have to set that up.
So what are you gonna demo here, Quentin?
So I think the idea here is to have the Rover send a message to Bolt, and we're setting up a program where Bolt will change its colors depending on what message Rover will be sending. So the idea is that as Rover drives by, just like you see in the video, you can send a bunch of info messages that activate or deactivate the bolts or Rover nearby. And this is all something that you can code yourself with an EDU app or using your own program to do this kind of exercises.
That's really cool. So a couple other things that I'll point out with Rover here is on the side there's a 4,400 milliamp battery, and there'll be a little key that you press and will unlock the door, and then there'll be a release button and the battery will come out, and that's going to be rechargeable through USB-C. And while Quentin's getting this set up, a couple other features is with this plate, the reason we designed it this way is so right out of the box, it's a complete robot that has, a very nice, well-rounded suite of sensors on. It works with our Sphero EDU app. So you can do all sorts of really fun programming right out of the box. But when you're ready to do some more advanced stuff, this is removable, and you can start building out all sorts of other different interesting projects with like a Raspberry Pi, Arduino, microbit, servos. This is a little mobile weather station. And so we'll get into a little bit more of that in a minute. Are you about ready for the demo?
I just need one more sec, Ryan. Okay. I'm almost there. And here it goes. Yeah. I think the rover kind of went to sleep. So let me just like reconnect to it real quick. There we go. Okay. All right. So let me set it up real quick. We're going to talk about another feature that Rover can do. Let's talk about the color sensor potentially, Ryan.
Sure.
Do you want to walk us through the color sensor?
Yeah. So on the bottom, we've got an RGB sensor, and there's a lot of fun things you can do with that. So one of the first demos that we built, this thing's hot off the press. So we're still just kind of formulating really fun ideas you can do with it. And so one of the first things we did was we laid out a bunch of different color cards on the floor, and we wrote a program where whatever RGB value the color sensor is detecting, it'll display that on all the LEDs on the robot.
And this is something that you can see in the video that actually is really satisfying to see as Rover drives on different colors. It actually mirrors the chameleon style to actually make sure that something goes well on the LEDs and on the color sensor.
Chameleon mode, I like it. That's a good name for that. A few of the other things you can do with it, if you guys have seen our Spectrum rings, it's the same technology that's built into our Spectrum's rings. So another idea that we haven't yet tested out, but will work the same way as Spectrum's, is it can also associate a color value with a sound. So potentially you could set up a bunch of different colored cards on the floor, program the robot to follow that colored path and play different notes or sounds based on what color it's detecting. How are we doing over here?
I'm just getting there. There's a little bit of latency as we have a lot of Bluetooth devices in here in the office. One of the problems I've having a lot of robots around, but it's getting there.
All right. So a few of you guys sent in some questions, and thank you guys for doing that. I'll go through a couple of those now, and let's see. We got a few. So first question from David is, will I be able to 3D print components and attachments for the RVR, and will there be mounting holes? So the quick answer to that is yes. And so that's what we've been doing as we've been getting different versions of prototypes in here, is we're sending stuff over to our printers. All of this stuff is actually 3D printed. So that's totally possible. And what we're planning to do is post the CAD, like the basic connection mechanism, on Thingiverse, GitHub, and other places. We'll get it out there so that you can basically design your own different types of toppers. So that's a great question, David. Let's see, here's another one. Will my Sphero, Spark Plus, and Bolt feel bad if I drive my new Rover more? How will I keep all my robots happy? That is a great question, Carl. I don't know. That's an age-old question. What do you think, Quentin?
Well, I have a lot of robots.
How to keep all the robots happy.
That's right. That's right. So I have a lot of robots at home, and I always have fun taking them out and driving them around. I have spent so many hours on Spark Plus creating some amazing programs for it, and it's been a blast. So make sure that all the programs and all the toppers and the kits that you create for Rover are actually able to interact with Spark Plus by like having some fun mazes or something.
Right. Interactivity, that's a good way to
rescue. I think a rescue scenario could be really fun for your Spark Plus and your Rover.
So if you're just driving a Rover, you could always put your other robot, your other neglected robots on top and drive it around that way too.
That's right. So, all right. So I have a quick demo here about the infrared. It's finally ready. So it's basically very simple. So we have the EDU app open, working with Bolt, and on receive message of ID number 6, the robot will turn blue. So if I send a message of ID number 6 with Rover, you can see my Bolt is actually turning blue on the screen. So I'm going to modify that message to actually say a different thing. Let's say message number 4. And this is where red is actually happening. So this is how we actually designed the feature so that these two could actually interact with each other and have some swarm robotics behaviors.
Very cool. So what other types of things do you foresee people doing with the IR technology?
You know,
if someone would really dig in deep, like what are some of the possibilities?
Yeah, so there's a lot of obviously interactions between robots that's feasible, but the fact that you have the sensors there, you can also do some more complex algorithm like following. So the follower is something that we provide Sphero as a feature for the users. So we say, hey, start following a robot of ID 1 and 2, for instance, and then the robot automatically follows. But this is something that you are also able to code, and I think a lot of people will want to get into these different algorithms, how to optimize the coding, how to optimize the tracking of the different robots and different platforms to actually be able to follow faster or slower, be more careful. And chances are you're going to be able to have a Bolt driving and have a Rover follow it in the maze, and Rover is fully autonomous, and you're just controlling the Bolt and making sure that the Rover doesn't get stuck against the wall or something like that. So these are the types of behaviors that we're hoping people get to create. And as always, we're looking forward to seeing what you guys come up with, and we're really excited to see all the fun projects that you have in mind.
That's really cool. So yeah, I'll go back and just talk about that again. Like that's what's really cool and what we're really excited about with Rover is, whether you're just starting out or whether you want to get super deep with like swarm robotics and stuff like kits, there's a really long runway there for you to go pretty deep with robotics. That being said, can you tell us a little bit about these kits that you've built up? So
sure.
So these are things that we built up. You might recognize some of them from our Kickstarter video. As I said, these bots are coming in hot from our engineering team, and so we we had a pretty short time to build some of these up, and so these were just like some of the first things that we've been able to build out that Quentin thought up and built. So maybe you could run us through these and what the thinking was, how you set them up,
Sounds
how they work.
Sure. So I think the first thing I want to mention is that Rover is brand new in its category, as in we are able to interact with other features that the users will put on top of it. So it's not like if you have your project, which is Rover, and you have your other project, which is the plate that goes on top. No, these two can actually interact, and we're going to provide an SDK. We're going to provide the code for you to be able to do that very easily. So there's a UART expansion port, which will connect to a Raspberry Pi. We have a USB port that will connect to Microbit and Arduino. So we're really looking into you make your project on your plate, and then you can power it, and you can also interact with the Rover. So for some of these projects, that was very interesting. So I'm going to start with the claw here. So the claw is very simple. It's just like a servo motor with a claw that just moves around as you move the servo. And then there's a Raspberry Pi that drives the servo. And this is one of the typical, I think, classroom examples. Driving a servo is one of the things that you do very often in the classroom. So we have the Raspberry Pi here that you just connect. So the idea is that you write your code, and this is what I did. You write your code at your desktop, and then you just plug it on your Rover, and you know how to send the right commands to it. And all of a sudden you have a driving claw, which you might have seen in the video, picking up a can of Red Bull and just like throwing in the trash can. So in the recycle bin.
That's really cool. So basically, you take this plate, you put the Pi on, you put on whatever accessories you want on top, you write the code, you deploy the code to the Pi, you plug it into the UART of the Rover, and then the Rover becomes whatever you create.
And we have a library of functions that you call to actually be able to drive the Rover, to interact with the color sensor, to interact with the IMU, to interact with the drive system. So all of this is already built in, and you just have to have fun with it.
That's really cool. So can you tell us a little bit about, let's do it, this one. This one looks fancy.
All right, so this is one, this was actually my first kit that I built, which is the Anemometer. So an Anemometer measures the wind speed. So if I were to start, be in a very windy environment, as you saw in the video, this will just start moving. And there's a switch in here that closes and opens depending on how fast it turns. And then you can read that information and send it back to the Raspberry Pi. That actually tells you how many times the switch is closing. And from there, you can infer the wind speed outside. So why would you do that? Something like that. Well, it's kind of interesting to have a mobile weather station, in this case, to actually be able to see if some place in your backyard or outside your house has more room, more wind. And the other thing I added to it, I'm going to show it real quick in the camera right here. So we have a little display here so that in real time you can show the data. You can see the data
Where is it?
It's right here in the bottom. So in real time, you can actually see the display of the data that's happening while the project is running, and that's really important when you're in the field and trying to debug your program to see what's going on. So we're going to take a quick break and take some questions from the audience.
Yeah, so this is really cool. So thank you guys again for tuning in. And are we good with audio? I assume everyone's okay. Cool.
Technical says go.
So this is really cool. So we got real-time stuff coming in. Let's see. Okay, here's a good question. So Corey Gorman is asking, will you also release ROS Node API?
That's a great question. So I think there are a lot of different SDKs and third-party applications that we want to be working on. We have a specific development timeline for this project, and we're trying to work with different partners. I don't know if ROS is on the list and how soon it will be developed, but I know we're working with different SDKs, and that might be one of them too. Yeah,
for sure. So we did talk about that, and so our immediate timeline is just to get this to our backers as soon as possible. But with the public SDK that we're releasing with RVR, we definitely have a lot of stuff like that. ROS is definitely on the list of stuff that we want to look into and expose to our SDK. So that's a great question. Let's see, what else? Scroll up, okay.
So we're going to be looking up in the comments. We missed a few questions earlier.
Bots who play together, stay together. I like it, Carl. Nice.
Nice, yeah, we like to see that. And make sure that if you have a bolt to check out Rover, because the interaction between the two of them are going to be amazing. There's a lot of creativity around it. We're looking forward to see what kind of amazing problems you solve with this.
Oh, here's another good question. So Robert Duran is asking, is there an IR emitter and can it emulate a TV remote?
That's correct. So there is an IR emitter. There are actually 4 of them on Rover, 1 on each side. So you have the front one, 2 on the sides, and 1 on the back. So we've been talking about releasing the ability for you to control the timing of the IR LEDs. So that's also part of the project because we want people to be able to talk to their TVs just like if it was a remote control.
So let's see, Cole Guerra 15. How do I get a cool, awesome job like you guys? So I would say you start with, I don't know how old you are, but that's really part of what we do here at Sphero is just trying to inspire people to get creative, to get curious about robotics, and we feel that the coding and 21st century skills are critical to that. And so that's a great question because that's really kind of the inspiration behind Rover is just getting people inspired early and getting them curious early, and that will help inspire them to create their own stuff. And so what would you say to that?
Yeah, I would say it's all about showing us what you can do and how you do it. And this is literally how I got my job here, is by creating something interesting around Sphero. And I spent a lot of time in grad school to actually write a project that was hacking Sphero. And then eventually I made a cool video out of it, and Sphero brought me here as a full-time employee. So this is how I think the culture that we want to have here at this company, this is how we do things. So show us your awesome projects, and we'd love to have conversations with you.
That's really cool. So there's another question on here. It says, does it have enough torque to drive through grass? So that's a really great question. It depends on how long the grass is. So maybe this is a good opportunity, and if you don't mind staying up here,
sure,
Dave.
Of course.
So I'm going to holler at one of our mechanical engineers who we can talk to. So, hey, Dave.
Good morning.
So this is David Clark. He is a senior mechanical engineer who's been absolutely monumentally helpful in building out Rover. And so one of the questions is, does Rover have enough torque to drive through grass? And you think that's an easy question, but maybe we could take a step back and you could talk about, how did we approach the motor spec, the gear ratio, the different types of use cases that we knew we wanted to account for. Walk us through a little bit of your thinking and how we kind of started from, really wide and lots of ideas and kind of narrowed in on where we landed with Rover.
Yeah, well, we had to start somewhere, and the first thing we did was we looked at the competition, and we needed to gauge what kind of size robot this was going to be. Remember, we didn't want it to be too big because then it gets unwieldy. We didn't want it to be too small because we wanted easy classroom access and things like that. So once we actually kind of figured out that this was about the size we needed, the first step is to kind of understand what kind of motor are we going to put into it. That's the very first thing. And once you kind of settle on the motor size, then you start figuring out the gear ratios that you need in order to get some of the speeds and some of the torques that you want. And we knew from a speed perspective that we wanted this to be the fastest EDU product that Sphero had. So we made it faster than Bolt, and we made it faster than Spark Plus.
Right.
And these calculations go into exactly what kind of motor and what kind of gearbox. And then once we kind of settled on some of those requirements, we actually built a prototype and we tested it outside. If you guys remember last summer,
This is a great video.
We took video of a
really fun
prototype
video.
unit going through grass, going through mulch, going over rocks. And at that point, we knew we had struck the right formula for kind of being able to drive through a bunch of different environments that you might see both at home and at school.
That's cool.
It's fantastic.
Yeah, thank you. So what else would you say, like, since you're up here, what were some of the other challenges that you think were unique to Rover and really set it aside as like a unique robot in the space?
For me, it was the fact that we're shipping a product where you don't have to put any motors into it. You don't need to think about what size motor you need, what size gearbox you need. We've done all the math. We've figured it all out for you. So you can take it out of the box and you can start driving it. We really want to be able to do inclines. You've seen us kind of go up hills and things like that. But challenges, ironically enough, these treads can almost be too grippy in a way. They can grab on to things, and sometimes that can help you, but other times it can hurt you. And so depending on what kind of environment you're in, sometimes you want less sticky treads.
That's awesome.
So things like that actually have to go into some of the math and some of the analysis that we do.
Yeah.
But overall, it's been a lot of fun kind of figuring this guy out because there's a whole lot of science and engineering that goes into driving this. And by giving you the whole package, you can rely on sort of having it done right.
That's cool. Actually, would you mind walking us through a little bit of what were some of the calculations you looked at, whether it was like friction or inclines and power and gear ratio? What were some of the kind of fundamental things you looked at to land where you landed?
Well, top speed was always something we knew was a well-defined target. We know that, the slowest speed it can go is 0.
Right.
But the fastest speed, we kind of set that to be about 2.4, 2.5 meters per second. And then knowing the motor speed, I can then go back and calculate what gear ratio we need to get the motor when it's spinning at 16,000 RPM and the wheels have to spin at 750 RPM. We know what gear ratio that needs to be. So that kind of helps us define that. And then based on the motor torque, the actual torque coming out of the motor itself, we multiply that by the gearbox ratio. We can now start to figure out, hey, this thing might be able to climb walls. And so that helps to kind of understand the relationship between the motor torque and the actual wheel torque, and then what it's able to climb and things like that.
And I guess having that much torque also allows you to drive very well at lower speeds when you have a lot of friction that you have to overcome. So this is also one big step and part of the selection process, right?
Yeah, and even Quentin, you bring up a good point. Just sort of the size of the step that we wanted to be able to climb up. We knew that we wanted to be able to climb obstacles that were about 3/4 of an inch to about an inch. And so that kind of drove the size of the wheel, because if the wheel's too small, it doesn't roll over objects. It's like riding a mountain bike, big tires versus small tires.
Sure.
And for you guys who want to have an idea of what it looks like, check out the video. There's a very cool moment where there are some log climbing over some pieces of log. It's really fun.
That's great. Thank you, Dave. That's
Thanks
super
a lot,
helpful.
Dave.
You're welcome.
Yeah, great question. So we got a few more rolling in here that we want to address. So, Gus, where can I get that hat? Oh, they're coming in hot. Hey, all right, Gus, since you asked, this is for you, buddy. So we're going to send you this hat, Gus. Good
That's
question.
awesome.
All right, here you go.
Congratulations, guys.
Send this off to Gus. All right, let's see. So here's another great question from Rob. So will there be a charging dock, or is it more of a plug?
That's a good question.
Yeah, maybe, hey, Lindsay, you want to come talk about the battery? So as we sit here, so this is the Sphero Design and Innovation Center, and we're surrounded by all of the insanely talented minds that helped build Rover. And so it's kind of a cool spot because we can kind of call on some of the engineers and designers that helped build this up. So I'm going to introduce you to Lindsay Cross.
What's up?
So
Where I go?
yeah, thank you.
Yeah.
Welcome.
Thank you.
So, yeah, so Rob is wondering, will there be a charging dock or is it more of a plug? So maybe you could walk through like how the battery works, how it comes in and out.
Let's do
the
that.
mechanism behind it.
Cool.
And yeah.
So I just hid that actually, but in a nutshell, we have a nice little battery compartment here. It locks in. There's a little tab here to release it, and you just pull it out.
But it will eventually be a little key for safety.
Yes, exactly. Right? And I don't know if you can see this here, but on the very bottom, there's like a plug here for USB-C. And I don't know if you know, but USB-C is the future. Like you can charge things super fast with that. So since we are the future, we wanted to allow you to charge fast. So you basically just take a USB-C plug. We have like 50,000 around here, so you can buy some on Amazon. We'll give you one in the box.
Right in the box.
But you just plug it in to either your laptop or you can plug it into a charger, and that's it.
Yeah. Well, one of the nice things about having a removable battery too is you're able to charge this, and we are going to offer these separately, so you'll be able to buy these batteries separately. You know, if you're doing like an all-day project, or maybe you have a bunch of students or a robotics challenge or all sorts of different scenarios, you'll be able to have separate batteries charging while you put in a freshly charged battery and drive Rover around. So yeah. So what do you think were some of the challenges in just having such a heavy piece in Rover, center of gravity? Like what were some of the considerations there? Because we have, I'm going to pop this off again. There's so much packed into here. We've got gearboxes, these motors, we've got these high resolution encoders, we've got this humongous battery, we've got PCBAs basically everywhere, we've got daughter boards everywhere. So what did you do? I mean, all these different like mechanical parts, you know, walk me through a little bit of your thinking of how we fit all of that in this tiny little package, and like, what were the considerations and how did we optimize?
Yeah, so we knew that being able to remove the battery was something important. And we knew that it was going to be huge. Like this guy, when you get yours, you can definitely weigh it. It's definitely pretty heavy. And Dave kind of alluded to it earlier. We want to be able to climb up walls. We want to be able to drive over certain things. So your CG is super important, especially in this rear wheel drive vehicle. So it doesn't go like this, or it doesn't go like this. So we really wanted to make sure it fit pretty directly in the center. And it was convenient that we have this nice opening between our wheel well here. We did actually move out the wheelbase a little bit so that we can fit a battery in, but it's just such a nice compartment. It's perfectly centered. It makes it easier for you guys to put projects on so that you're not fighting against a wonky CG. But yeah.
And
that's great.
I want to mention that some of the reasons why the battery is so big is because we want to provide power to the kits that you guys are going to build later. So if you have a Raspberry Pi, if you have a Pi camera on top of that, all of that takes a lot of power. So this is a battery that's designed to handle that much current draw. So this is why it's also so big, not only for the two motors, but also for all the top crazy projects that you're going to come up with.
Right. We don't know what you're going to put on top, so we need to be sure that it'd be able to handle what you're going to put on there.
Totally. So here's another one that might be relevant, Lindsay, is Praj KTA. Thank you for the question. Will you release CAD for custom toppers? So what is our thinking around that?
I'm into that.
Yeah.
We'll put some on Thingiverse and give you guys this the CAD for this mounting plate so that you can make it however you want.
Right.
So those
pop it on.
Didn't you 3D print basically everything on this table?
Every single thing here is actually 3D. Yeah, except for like, you know, motors and these gears are molded, but these are 3D printed prototypes, which is awesome. And it can show you what you guys can do with 3D printing. And it's just like, so definitely, I think part of our plan is to release that, and we'd love to, you know, see what you guys suggest. And that's, you know, one of the ideas behind this removable top is you can do all sorts of stuff with it. You can, you know, you could print like a, you know, a Lego brick topper, or, you know, a GoPro mount. There's all sorts of fun stuff you can do with that. So cool, Lindsay. Thank you so much. Yeah. Thanks, guys.
We'll jump into a few more questions here. We've got, let's see, Kenny, battery life and playtime. So that's another great question, and that's a, you know, a big priority when we're, you know, speccing out the battery. So we are actively testing and trying to understand what that's gonna look like. So we put USB-C on there so it does charge as fast as possible. And then as far as playtime, that's sometimes hard to gauge because we don't know if Playtime to you is driving it constantly or, programming and running, running a program for 30 seconds and programming for 15 minutes. So that varies, but with all of our products, we're trying to maximize that as much as possible. So right now, our early tests look like Playtime could last up to 2 hours. That spec goes out the window once you start adding all sorts of the other crazy toppers on.
Right,
so,
exactly. And it really depends on your use case. If you're trying to do, I want this very advanced remote robot that has a camera, streams over the Wi-Fi, that obviously takes a lot of power out of your batteries. So it's not going to last as long as if you just have the platform the way it is, driving for a little bit in a classroom set. So I think the number that you're looking for is 450, right? Milliamp hour battery, so 4,400. 4,400 milliamp hour battery, which is a very big batteries. For the record, the batteries that we have on Bolt are like 1,250, and that's like a one cell. So it's basically 8 times the amount of power that we actually ship on Bolt. So it really depends on your usage for that question.
Yeah, so lots of great questions coming in. And then let's see, we want to send Carl a free Rover mug. These are brand new. So Carl,
congratulations, Carl.
Yeah, thank you for all the engagement. We're going to send you a free mug, and so send us your info so we can get that out to you. Let's see. So some more questions coming in. Give me a second. Let's see where we're at. What's the weight limit on Rover? So what's the payload?
Yeah,
that's another great question. So we're doing a lot of testing with that now. As Lindsay mentioned, these are all 3D printed parts. So the tolerances, some are more than we'd like, some are less than we'd like. And so the friction on the system is varied. So it's hard to test at this point. Once we get molded units back, we'll be able to test that better. We've done all sorts of different testing with different levels of prototypes, and it looks like it's going to be able to carry quite a bit. I think the latest spec we have is right around 2 pounds we feel comfortable with, but maybe a lot more. So we'll test that more and get back to you once we have actual molded parts. Right. And that way it'll just be that much more of an accurate question. Yeah, so we'll definitely carry a cat, house cat, not a African mountain lion
cat.
Yeah. So let's see. So great questions coming in, you guys. Again, thank you so much. And then also all these parts, I want to give a quick shout out to our partner, Spark Fun. I don't know how many of you guys are familiar with them, but they actually are neighbors of ours right up the street in Boulder. And so it's been a really cool partnership. We're working with them on developing like awesome kits, awesome content all around Rover. Because as you see, this is really just the beginning. And so we envision people creating all sorts of crazy stuff with kits, and they're working with us really tightly to deliver some awesome stuff to you guys.
And it was really easy for me to actually go online, buy the parts that I wanted for the project, kind of define what I was looking for, but also I was just browsing the product line that they have, just looking for inspiration on what would look cool for us to build. And this is kind of how these toppers came to life, is that we found a bunch of cool ideas from there and just like started building them and making them work. And it was really easy.
Yeah, so thank you guys very much. So this is really fun, guys. Holy cow, we get 830 people tuned in. That's awesome.
That's amazing.
Thank you guys again so much. Keep your questions coming. We'll answer them as best as we can as they come in. So I'm thinking now we talk a little bit about the software.
All right.
Sounds good. I see Anthony standing over here. So Anthony, come on in. You can just stand right now.
Welcome, Anthony. Welcome.
This is hilarious. So guys, meet Anthony. Anthony runs our SDK, and he's been, jumping in on the Rover project, and he's actually doing a lot of the planning behind the hackathon that's coming up, which we'll talk more about that in a little bit. But maybe you could.
It's a co-effort between Quentin and I.
Yeah,
it's all good.
So
we're
scheming for you guys, and it's going to be awesome. More on that later. But maybe you could tell us a little bit about what the SDK that comes with Rover. Maybe I'm a developer watching, and I'm wondering. How easy is it really to build this stuff? Like I've got, projects in my garage that I'm thinking about. How does that work with Rover? What's the interface? What do I need to know?
So to start off with, we'll be providing basically SDKs for 3 platforms on launch. And those will be the Raspberry Pi, Arduino, and Microbit. And so with those 3 platforms will also provide a lot of rich content and samples for you to get started with. So when you have one of those boards available, you'll just be able to hook up Rover to that particular board, download those SDKs with those samples, and then be able to just kind of run those samples and be able to build off of those samples. Or if you're eager to even dive a little deeper, we'll be posting our API documentation online. So if you don't want to use the SDK, or if you want to use it in a whole different way, you'll just be able to follow the docs and build whatever ideas you have using your imagination. So yeah, really so cool. It's really just a matter of setting up your board, hooking it up onto Rover, looking at some samples, looking at some docs, and then building.
That's awesome. Thank you, Anthony. So we saw another question come in while you were talking. So because this is live, we're all on the spot here. So so Robert Duran is asking, will the SDK have any tools to help mapping?
Oh, that's a great question. Initially, we will not be doing any camera, visual sensing, anything like that with cameras. But I think as we continue to evolve and mature the Rover platform and really understand what the users, the makers, the developers, the hackers, the hobbyists, what do you guys want? And once we have an idea of what those are, we can continue to evolve what samples we provide, what libraries we continue to put out there. So that's a great question. And I at least personally, I envision computer vision being something that we do add eventually to the Rover library.
Nice.
That's cool. Awesome. Great question. So I'm going to give you a hat for that one.
Thank you.
Congratulations.
Oh,
here you go. So thank you guys again for all your questions. So so we're doing something super kind of crazy. This was like an idea we came up with early on. We were like, hey, what if we did a hackathon before the campaign is even over, and we pick out a couple backers to fly them out here to Boulder, Colorado in the design center, and we just play around with Rover, because with Rover, everything about this robot has been user driven. People wanted a robot that drives outdoors,
right.
So we put a lot of energy in figuring out how to do that. People wanted a robot they could, hack on top of, but they also wanted something that was easy to use out of the box. And so just in the spirit of that, we were like, hey, let's just bring some backers out to Boulder and let's have some fun. Let's get some robots out. And so we've been working really hard to kind of compress our timeline even further on getting, our electronic boards, our PCBs spun up, and getting models built from our factory, right, yeah. Getting those here, prepping some of the SDKs so that we have a lot of stuff to play with when you guys get here. So maybe you could tell us a little bit about like what are you guys thinking, like for someone who is going to apply for the hackathon, what's going to be in store for them?
You want to start?
Sure. So I think the idea is for people to come over and put their hands on the Rover for the very first time. So this will be an event that will be live streamed just like we are right now. And we're we want people who come here to have the most amazing first-hand experience on Rover. So there will be challenges that we actually are going to organize for you to actually have use Rover in the maximum of its capabilities. So we're not going to give away any of the challenges yet, as we want to build up the surprise for it. But it's basically we'll try to cover as many of the awesome features that Rover has, and the awesome features that having the ability to have kits on top of it will actually enable.
Yeah, and we want to be able to provide a rich experience using our SDK. So we'll have alpha, beta version of our SDK available that will be basically coding alongside of those of you that are able to attend. And so we're looking forward to see what ideas you guys will bring to the table as we have the challenges. Not every person's going to solve it the same way.
That's true.
So we're really excited to see how you use Rover to solve a particular challenge using sensors and Raspberry Pis and whatnot. So yeah.
If you're interested in participating, feel free to apply. And we highly recommend brushing up on your Sphero experience, brushing up on your Raspberry Pi, brushing up on your Arduino, because a lot of these will actually be present during that day for you to hack on.
Yeah. Well, let's pause there. Arduino's a maybe. Let's be
Or it is a maybe. All right.
I want to make sure we set
It is Pi Day.
expectations.
It is
Pi Day. That's
It is
true.
Pi Day.
So
Pi Day, yeah. So you'll need to brush up on some Python, maybe some JavaScript.
That sounds good.
Yeah.
Linux.
Yeah, definitely.
Yeah.
Definitely
Okay. So,
makes sense.
and so the hackathon is Pi Day. Pi Day is March 14th. And to apply, if you scroll down on the main Kickstarter page, there's a link. There's a hackathon header. You'll be able to see it in there. Then also on yesterday's update, we put a link in there as well. So feel free to apply. It's just like a quick Google form. And then, and now it's in the chat. So that's great. Feel free to apply.
Thanks, Julie.
We're not really thinking of it as a contest. We just want to see who's out there, see who wants to be involved, and then we're gonna just kind of try to pick a balanced mix of people that will give the most amount of feedback on what Rover is and what it can be. Which all of that input is going to flow into some of the tail end of our development with the SDK. We're going to get great feedback from you guys, so we're really looking forward to that. So apply for the hackathon. It's going to be super fun. If you're not chosen for the hackathon, we're going to live stream the whole thing, and so we're going to be doing all sorts of fun stuff throughout that whole day. So if you're not one of the ones that we fly out, don't worry. We're going to live stream it. We'll be having lots of engagements. The whole thing is going to be just a really fun event, and we're going to be doing giveaways and all sorts of fun surprises. So check that out. There will be both delicious pie and Raspberry Pi boards.
Yes.
So,
Correct. That's
yes.
right.
So, so there will be pie. That's a great question. Who asked that question? Or is that just you?
That was Mr. B.
You win a free hat, Julie. All right.
Whoa!
Cool. So,
Fantastic.
well, thank you so much.
Thanks
Anything
a lot,
else?
Anthony.
Thank you.
Yeah. Is there anything else you want to talk about with the SDK?
No, if you have ideas, throw them in the Slack channel or however we're communicating right now.
Yeah.
I'd love to hear any ideas you currently have with features or feedback that you might have for the Rover SDK that we're going to be providing.
That's awesome. Thanks,
Fantastic.
Anthony. So
Thanks
yeah,
a lot,
keep the
Anthony.
questions coming, and we're building this thing in real time, and a lot of that is thanks to you guys. So
Great.
cool. Thanks, Anthony.
Awesome.
Appreciate it.
Thanks a lot.
Oh,
Okay.
you want me to leave now? Okay.
Okay,
Somebody
bye.
get this guy a hat too. Okay,
right.
so
Should we go into more in depth into some of the features that Rover has on the platform, some of the sensors and the control system?
sure. Yeah,
Eventually.
we can talk a little bit more about Rover here, and then after that, we will see if we can do a couple more questions, and then we'll probably wrap up. So
Sounds good. So I do want to highlight the control system of Rover, which is something that is something we feel very happy with at Sphero. So one of the core function of a robot like Rover is to drive in a straight line. So usually when you have a platform that looks like a Rover but it's not a Rover, you have to work really hard so that both motors are kind of balanced, and you have to correct yourself for the different obstacles that get in there. But in this case, we have a control system that takes real-time feedback from both an accelerometer, a gyroscope, and the encoders of the motor to actually adjust for the direction changes that Rover may incur, so that Rover, at best as it can, stays in a straight line. And we have an example of that in the video.
yeah, so if I were to just make one of these up myself, and I just put a couple motors in there, give it some power,
Right.
how is that driving? Like, what is it using to navigate, or is it using anything at all?
Absolutely. So the problem with just controlling the robot with raw power in the motors, so PWM, is that you don't know if your system is actually perfectly balanced mechanically to begin with. As as obstacles come along the way, there's some more resistance on one tread or the other. If you have different surfaces you're driving on that are not the same on the left and on the right, you're going to create a balance change, which will make your Rover drift one way or the other. And this is why we have the control system and the IMU that takes care of that problem. So let's say that if I'm driving and then there's an obstacle on the left of my tread on Rover, and then it kind of stops there because it's blocking against my hand, well, the control system will know that something is going on and provide more power to the left wheel and less power to the right wheel to overcome that discrepancy.
That's awesome. Yeah, so that's really one of the things that you'll hear us talk a lot about with Rover. That's a challenge that we've solved with Rover. And if you are a developer and you do want to build some advanced programs and actually do some tasks, that all of those hard problems are solved with Rover, so that you can use this as a platform to get to whatever crazy idea you have with robotics.
Right. That makes perfect sense.
So what else do you want to tell our backers?
I think this is an awesome platform because of all the sensors that we built in. There's a lot of cool stuff that will come out of it, not only from Sphero as we build it, but also from the community. And we really look forward to seeing the amazing things that you will all build with that platform.
So let's see, we got a bunch of questions coming in about self-charging.
Self-charging, oh, that's a fun problem. All right, well, I think.
So first of all, does Rover self-charge?
Rover, unfortunately, does not self-charge. And this is something that we were pretty adamant about, as we decided that the battery was going to be removable for this project to be able to swap out and like work faster and faster. We decided to not go that route of the self-charging. And we actually disabled any charging capabilities of the battery by hiding the plug under the platform so that you can run and charge for safety reasons, obviously. But there might be hackers out there that will figure out a way to make this happen. But we decided not to go this way for safety reasons.
That's awesome. Yeah, great questions, guys. Let's see. So we have, where are we at for our backers right now? So we're going to start wrapping this up, you guys. We are currently at 1,089 backers.
Wow, that's amazing, guys.
Thank you guys
Fantastic.
so much. Super exciting. I want to urge you guys to check out the Kickstarter special backer level. So we're giving Rover out at the Kickstarter 199 special. There's definitely a handful left, but they're going really quickly. Everything is going way faster than we expected. I think there's like 4,000 or so left at that level. So get in while you can. Make sure you are the first people to receive a Rover. And then there's also a few slots left on the Rover Bolt combo backer level. Right. And so as Quentin described, there's some really cool interactivity you can do there. Yeah, guys, we can't thank you enough. One last thing is we are going to do a live stream on YouTube tomorrow as well. So feel free to tune in there. And we're going to be doing this every Wednesday. We're going to have Adam Wilson, our Sphero co-founder, doing this next Wednesday, and just all sorts of fun stuff. So stay tuned as the campaign progresses, and we'll keep everything really fun and really exciting for you guys. And just thank you guys. Thank you guys.
Thank you so much for the questions. This was wonderful.
All right, guys.
Thanks a lot. You have a good one.